Hello everyone. Today I am here with class 12th, chapter number 5, lecture number 2. In this lecture, I will discuss question of exercise 5.1. In exercise 5.1 up to question number 13 we have already done. Let us do some of the question of the exercise. So here comes question number 14. In question number 14, you can see the function is given as the value of the functions are 3, 4 and 5 for different values of x that are defined here. They are, since we have to check the continuity of the function, we will take all the cases possible. Now you see, when x is greater than 0, we have a function defined as 3. But for less than 0, we don't have any function. The first case that I am going to take is that x lies from 0 to 1. The second case that I will take is that x equals 1. The reason is I have a function which is less than 1 and equal to 1 and greater than 1 also. So at x equal to 1, LHL and RHL both can be formed and we can actually do it. The next is when x lies from 1 where see 1 is not included to 3. Clear? Then the fourth part that we will be checking is at x equals 3, as we have different functions for x less than 3 and greater than 3. The fifth part or the fifth case I say will be when x lies from 3 and including 10, because for x less than 10 we have a function which is defined as 5, but for x greater than 10 we don't have a function. So these are the 5 cases on which we are going to check the continuity of the function. I hope these all 5 are clear. Now one by one I will be proving the continuity of the function. So let us start with the first case. In the first case, you see the value of x is from 0 to 1. Now between 0 and 1 is the function value changed. You see it is always 3. So case 1 when I solve, which is x lying from 0 and the less than 1. Correct. The function value is 3 here. Since this is a constant, it is going to remain same in the LHL and RHL whether we try, right? So this is a continuous function. In the LHL and RHL the function is not changing. It is 3 only, a constant number, hence this is a continuous function. In the case 2, where I have x equals 1, I see for less than 1 and for greater than 1, I have different values. So it is better that we try to write LHL and RHL and prove that whether it is continuous or not. So I'll take another sheet on which I will be writing the things. Now, case 2. In case 2, x equals 1 we have to check. So I will write LHL, I'll write RHL, and we will find the function value at equal to 1. Let us go back to the previous page. I see that at x equal to 1 the value of the function is 3. So I will write on the another sheet that f of 1 is 3. In LHL, limit x will tend to 1 minus and the value of the function, that means less than 1 we have to go for. Let us see what is the function less than 1. As we can see here, x less than equal to 1, we have the function value as 3. So let us write that. So here what will come? 3. So the answer will be 3 only, because there is no term of x here. It is a constant number. Now in RHL, limit will tend to 1 plus, as I can show you that for x greater than 1, the value of the function you can clearly observe for x greater than 1, it is 4. Let us write this value in our answer. So here we are going to write it as 4. The answer is 4. Now we see that LHL and value of the function are equal, but the answer for RHL is not equal to LHL and the value of the function at 1. So you will write that limit x tending to 1 f of x is not equal to, or you can write it more clearly, that 1 minus f of x is not equal to limit x tending to 1 plus f of x, and it is not equal to f of 1. Correct? This is not equal to this, and this is not equal to the both are not equal to the RHL. Hence, it is discontinuous at x equals 1. Hence, at x equal to 1, the function is discontinuous. I hope this is quite clear to everyone. Okay, now the third case that we are going to operate is this one. In the third, we have to check for the value between 1 and 3. Now, we don't need to solve for values between 1 and 3. As you can see, between 1 and 3, the value of the function is a constant number, which is 4. Hence, it will be continuous. Now, the fourth is x equals 3. As the same case I have done for 1, we are going to check for x equals 3. 3 plus and 3 minus, and you can see when you do for 3 minus, when x is less than 3, the value of the function is 4, and when x is greater than 3, the value of the function is 5. Hence the RHL and LHL will not come as equal in this case. And in the fifth case, which is x lying between 3 and 10, between 3 to 10, the value of the function is again a constant number, which is 5, and the LHL and RHL will remain same. Hence, it is a continuous function. So, in this question, we observe that the function is not continuous at x equals 1 and at x equals 3. For all the other values except 1 and 3, it is continuous. So, we will say the function is continuous for all real number except 1 and 3. So it is discontinuous at 1 and 3. Other than that, at all the values, it is a continuous function. So this is how you are going to do question 14, 15 and 16. One of them I have explained, the rest two I will be giving you as a part of your homework. Now let us go to another type of problem. See, in this question, what do we have is f of x. Okay, for less than 3 it is defined, for greater than, as we see LHL and RHL, or the value of the function less than 3 and greater than 3 changes, so we are going to find LHL and RHL. We have to find the relationship between A and B, which are used in the question, as you can see here. Right, so that the function f is continuous. If f is continuous, then LHL, RHL and value of the function at 3 should be equal. Let us try doing it. See here, value of the function at 3. At 3, if I find out equal to 3, you see equal to cases in this one. So we are going to opt for the function ax plus 1, where instead of x, I have to place 3. So it will be becoming 3a plus 1. Now let us solve our LHL. In LHL, we will write that limit x will tend to 3 minus, and the function is ax plus 1. When we solve it, I'll write limit h tending to 0. H is a value that is very close to 0. So a, instead of x, we will write 3 minus h plus 1. Now it will become as limit h tending to 0, 3a minus ah plus 1. When you place the limit value as 0, we get the answer as 3a plus 1. Let us solve our RHL now. Okay, in RHL, we will write limit x tending to 3 plus. The function value that we are taking in this case is bx plus 3. As you can see here, for greater than 3, it is bx plus 3. Now, changing the limit to h tending to 0, we'll get it as b 3 plus h plus 3. Now putting the limit value h as 0, we get 3b plus 3. So we have found out f of 3, LHL and RHL. As they are saying it is continuous at 3, so we are going to equate all of the three equations together. Let us do that on a separate page. So I have to equate 3a plus 1 to 3b plus 1, because say this is same. So 3a, I'll just write it. So we will write 3a plus 1 equal to 3b plus 3. Solving it, 3a is equal to 3b plus 3 minus 1. 3a is equal to 3b plus 2. Now, we have to find a in terms of the relationship between a and b. So a will be 3b plus 2 upon 3, which can also be written as b plus 2 by 3. So the value or the relationship between a and b is this if the function is continuous at 3. I hope this is clear to everyone. We will now go with the next problem of the chapter, which is exercise 5.1, question number 18. In this question, they are saying for what value of lambda the function defined by f of x lambda into x square minus 2x when x is less than or equal to 0 and 4x plus 1 when x is greater than 0 continuous at x equals 0, and we have to check for x equals 1 also the continuity of the function. So let us complete first part. Here they are asking the value of lambda for which this will be continuous. So let us solve. F of f of 0. The value of the function at 0, we have to take this one, right? So when we place x as 0, we will get the answer of the function as 0. Now solving the LHL, where limit will tend to x 0 minus. For less than 0, the function is x square minus 2x. Now writing the value limit h tending to 0. Okay, what will I write instead of x? 0 minus h. So 0 minus h square minus 2 into 0 minus h. So when we solve it and put the value of lambda as 0, see what is the answer that we will get. Here it is lambda, right? So it will be 0 plus h square minus 0, opening the root or the power, the square. Then it will be 2 into 0 is 0 minus minus plus 2h. So when we solve it, we are getting this as 0. Correct. Now let us write the RHL. Limit x tending to 0 plus. The function will be 4x plus 1. Limit h tending to 0. Instead of x, I'll write 0 plus h plus 1. So the answer that I get for this is 1, because 4 into 0, 0. 4 into h value is 0, that is again 0. We are only left with 1. So do you see, in any of the case, right, if the function is continuous, all of these should be equal, right? And we are getting that in any of LHL, RHL or the function value at x equal to 0, there is no lambda in them. So lambda doesn't affect this. So for no value of lambda, this function will be continuous, right? Because lambda is not making any difference in the answers of LHL, RHL and the value of the function at that particular point. Now comes the second point, where we have to check the continuity at x equals 1. Now you observe carefully, x equals 1. That means in that will come in x greater than 0. So for 1, we are going to take this function. Whether we take 1 plus, we take 1 minus, we are going to take the same case, because for greater than 0, this is the only case, that 4x plus 1. And you see this is a polynomial function and it will not be not defined at any value, right? Hence this will be a continuous function at x equals 0. So you just write down that x equals 0, the function is 4x plus 1. There are no different values for LHL and RHL. The function is going to remain same as 4x plus 1. Hence this is a polynomial function and is continuous. Let us go to the next question of it now. So in the next question 19, they're asking us, show that the function defined by g of x, x minus, as you all know, this is a sign of greatest integer function. We have already done this in detail through the graphs also, is discontinuous at all integral point. That means all the integers. Here, this denotes the greatest integer less than or equal to x. Now, I will give you some examples first to solve this. Suppose in greatest integer function you have a number c, or let us take a numerical number, not with the variable. Suppose I have 3. The answer will be 3. If I do 3 minus h, that means I am doing 3 minus h here is tending to 0. That means suppose 0.0001 something. So the answer that you get is 2.99 something, right? Okay. And if I write 3 plus h, that will become, here you will get like this, and the answer for this will be 2. But in the case 3 plus h, when you write, it will be 3 point something 00001 suppose, right? So the answer for this will be 3. So observe carefully, when we will be solving the LHL and when we subtract something from the number which is there, the integer in the greatest integer function, the answer will be 1 less than the number, right? And here it will be the same. So using these, now using these we are going to solve it at any integral point. So let us see, the point is C. Okay, C represents any integer. Let us solve it on a different sheet. Function is x minus greatest integer of x. So if I solve f of c, you see c minus greatest integer of c. See, if it is an integer, c will remain as c. So answer will be 0. LHL, you see, limit x will tend to c minus x minus greatest integer of x. So let us change it to h tends to 0. Instead of c, now c minus h will come. This is simple, and this is in greatest integer function. As I told, if from the integer we are subtracting a very smaller value, we will get one number less than it. So c minus h minus of c minus 1, and the limit is tending to 0. Putting the value of h as 0, what is the answer that we will get? C minus c plus 1. So the answer will be 1 in this case. Let us solve RHL. You need to be careful here when I write c as c minus 1, because I am subtracting something. As I explained you, from 3 if you subtract something, you will get 2 point something, and 2 point something in the greatest integer function will lead you to the answer as 2. Now RHL, okay, so limit x will tend to c plus x minus greatest integer of this, then limit h tending to 0, instead of x you're going to write c plus h minus c plus h. So it will remain as 3 plus 0 point something. If I write, that will be 3.001, and in the greatest integer it will be giving me the same answer. So if I am doing c plus h, the answer will be c itself. So c plus h minus c. Correct. Limit h tending to 0. Now when we solve it, you see the answer as 0. So do you see it is continuous? No. We are only getting that f of c and RHL are equal, but LHL is quite different. It is 1. Hence the function is not continuous at all the integral values. C is any integer, right? So for all integers we have generally checked it, not a particular one. Hence this is proved that the function x minus greatest integer of x is not a continuous function at all, or is a discontinuous function at all the integral values. Let us go to the last question for today's discussion. Okay, so yeah, this question we have already discussed. Here comes the last question of the exercise which we are going to discuss today. Right, what do we have to do in this? We have to discuss the continuity of cosine, cosecant, secant and cotangent. For cos, suppose cos of x is the function. Clear. Now we will check it any value. Let the value be c. Let c be, or we should write it in a brief, c belongs to any real number. Correct. Capital R is for real numbers. Now I will check f of c, which comes out as cos of c. Now checking the LHL. So now we will check at f of function value for LHL. For LHL, the function is going to remain same. I'll write it as limit x tending to c minus cos of x. So the next step will be limit h tending to 0 cos of c minus h. Clear? If we solve it, we'll get the answer as cos of C only, which we were getting as f of C. Now, in RHL, I'll write limit x tending to C plus function value is cos x. So, putting it as limit h tending to 0 now. Okay, and the function will become cos of C plus h. Putting C value as 0 will get, h value as 0 will get cos of C. So you see it is a continuous function as LHL, RHL and the value of the function at that particular point is equal. Same will happen to cosecant, secant and cotangent. Also, in the next lecture, I'll first teach you the algebra of these functions where we can check. So the algebra means where if a function f is continuous, then g is a continuous function, so their addition, subtraction, their multiplication and their division will also be continuous. So using these you can apply here as cosecant is 1 upon sine, secant is 1 upon cos. So if cos is continuous function, 1 upon cos will also be a continuous function. So this is all for today's lecture. In the homework part, what you are going to do today is, let me tell. This is your homework. As we have done the similar kind of the question which I have given you in homework, so you will be definitely able to do this. So you have to attempt question number 15, 16, 20, 21, 23 of exercise 5.1. I don't think this is much homework. You can easily do it. And please come up with doubts tomorrow. Okay, that's all for today. Bye.